Today we'll start a new topic related to bonding. In this session, we will discuss about different types of bonding such as ionic, covalent, metallic, as well as dative. First, what is ionic bond? The bond which is formed by a complete transfer of electron from one element to another. So example, we have magnesium which belongs to group 2, so it will have 2 electrons in the outermost shell. So these are the outer shell electrons only for magnesium. And oxygen belongs to group 6. So as oxygen belongs to group 6, it will have 6 electrons in the outermost shell. So what happens? The general tendency of the metal, they tend to lose electron. And what is the tendency of the non-metals? The non-metal tend to gain electrons. So metal will transfer electron, or magnesium will transfer electron to oxygen. As the magnesium loses its last shell electron, it will be a charge +2 because there is net charge, and oxygen gain 2 electrons, so net charge on oxygen will be -2. And the attraction between the positive and negative ion, this attraction between the positive and negative ion is known as ionic bond. So the bond which is formed between metal and non-metal by a complete transfer of electron, as a metal lose all of its valence shell electron and the non-metal will gain electron to complete octet. Octet means 8. And how these ionic compound exist? So magnesium loses electron, and oxygen gain electron. So magnesium will get a positive charge and oxygen will get a negative, and the attraction between them is ionic bond. But what happens in ionic compounds? They exist as a lattice. What is the meaning of lattice? Lattice means the regular arrangement of positive and negative ion. So ionic compounds exist as a lattice. So we have a regular arrangement of positive and negative ions. So there are a lot of ionic bonds, the attraction, the electrostatic attraction between the positive and negative ion, which leads to high melting point of these ionic compounds. So these ionic crystals, they have a structure of a giant lattice in which the ions are arranged in a regular pattern, a positive and negative ion, and a strong electrostatic force between the ions is known as the ionic bond. An ionic bond is stronger and the melting point is higher when the ions are smaller and they have a greater charge. So example, if I say sodium chloride and we have magnesium oxide, which one you think will have the high melting point, sodium chloride or magnesium oxide? Which one you think will have a high melting point, sodium chloride or magnesium oxide? So magnesium oxide will have a higher melting point. Why? Because the size of the ions are smaller and their charge is greater. That's why the magnesium oxide will have the higher melting point. So melting point increases, or electrostatic force or ionic bond strength of ionic bond increase as the size of the positive and negative ion decrease, and the charge on them will increase. Then when we compare the ionic radii compared to atom, so example, if we have sodium atom, the first shell it is having 2 electrons, second shell it will have 8, and third shell it will have 1. So 2, 8 and 1. Whereas sodium ion, if it loses electron, it loses the last shell electron. So sodium ion, first shell 2 electrons, second shell it will have 8, and third shell it does not have any electron because it lost that loses that electron. So when we compare the size of atom with a positive ion or the cation, so what we find, the size of the cation is always smaller as compared to size of the atom. And opposite will happen, size of the anion, like example you have say chlorine, first shell 2 electrons, second shell 8, third shell 7. And you have chloride ion. So chlorine atom, first shell it is having 2, second shell it is having 8, and third shell it is having 7. But for chloride ion, first shell 2, second shell 8, third shell it is having also 8 electrons. So here in chlorine atom, 17 protons are attracting 17 electrons. But in chloride ion, 17 protons are attracting 18 electrons. So attraction on each electron will be weaker. As the attraction on each electron will be weaker, the size, when we compare the size of the negative ion or the anion with size of the atom, so what we find? We find that negative ion size is larger as compared to that of atom. Is it clear, the concept, the comparison between the size of atom with the positive and the negative ion? So if it is forming a positive ion, the size of ion will be smaller as compared to size of atom, and if it is forming a negative ion, opposite will happen, that the size of a negative ion will be larger or bigger as compared to that of simple atom. So within a group, as we go down the group, the atomic radius increases. Why the atomic radius increases as we go down the group? Because down the group, the number of the shells increases. Like we have lithium, first shell 2, second shell 1. Then we have sodium, first shell 2, second shell 8, third shell 1. Then we have potassium, first shell 2, second shell 8, third shell 8. And the last shell, it will be 1. So when we compare their sizes, like size of lithium with sodium and potassium, because as we go down the group, so as we are going down the group, what we observe? We observe the size of the atom or even the size of the ion will increase. And what is the reason for that? The reason, because there are greater number of shells. But when we move across the period, like we have sodium, magnesium, aluminum, silicon, phosphorus. So sodium is 11, magnesium is 12, aluminum is 13, silicon is 14, phosphorus is 15. Sulfur is there 16, chlorine is there 17, and argon is there 18. So when we compare, as we move across the period, so moving across the period, the size will decrease. What is the reason why the size is decreasing? Because the nuclear charge increase. The same shell is there, because they all have the same shell, they all belongs to period 3, so they will all have 3 shells. But because in sodium, the 3 shells electron are experiencing a force from 11 protons, but in case of magnesium there are 12 protons, in case of aluminum 13 proton, silicon 14 proton, phosphorus 15. So the nuclear charge is increasing. That's why when we move across the period, the size will decrease. And when we compare the size of isoelectronic ions, which are having same number of electrons, so when we compare these isoelectronic structures such as nitride ion, which is having, because nitrogen is atomic number 7, so it is having 7 protons, and minus 3 means 10 electrons. Oxygen, which is atomic number 8, so it is having 8 proton, but the charge is minus 2, so it will have 10 electrons. Then fluorine, fluoride ion, 9 protons are there. Atomic number is 9, that's why 9 proton, but 10 electrons. Then sodium is there, charge plus 1, so 11 protons are there and 10 electrons. Then magnesium is there, 12 protons and 10 electrons. And aluminum is there, charge 3 plus 3, so it is having 13 protons and it is also having 10. Why we call them as isoelectronic structures? Because they all have the same number of electron. So when we compare the isoelectronic structures, the ions with the same number of electron, so how we can work out which will have a greater, like which will have a smaller size and which will have a larger size? So we check the balance between the proton and electron. If electron number is more, it means the size will be small because greater attraction from the nucleus. But if when we compare the proton with electron, if electron number is more, so smaller nuclear charge, so electrons are like relatively away from the nucleus as weaker force, so the size will be larger. So when we compare, here 7 protons are attracting 10 electron, 8 protons are attracting 10 electron, and 9 protons are attracting 10 electron. So which one will be larger in size? Because the difference electron number is greater when we compare with proton for nitrogen. So nitrogen will have the larger size, followed by oxygen and then fluorine. But when we check the positive ion, so 11 protons are attracting 10 electron, 12 proton attracting 10 electron, and 13. So stronger attraction, aluminum will be the smallest one in this, and magnesium moderate, and sodium will be larger in size. Is it clear? This graph, the comparison of size for the isoelectronic structure. So basically it's a comparison between proton and electron. If proton number is greater, the nuclear charge is greater, it means that the size will be smaller. But if electron number is greater, it means weaker attraction towards each electron, so size will be larger. Then definition of enthalpy changes for stages involved in formation of ionic lattice. Basically, how ionic lattice is formed. The concept of formation of ionic lattice, how ionic lattice is formed, there are two possibilities. Like we are taking a general description that we might have element and elements first turn into atom, then atoms turn into ions, and ions will form a compound. So Formation of ionic lattice, what are possibilities? First, element absorb energy and they turn into atoms. Then atom loses one of the atom, positive will lose electron, negative will gain electron. So we call that they will form ions. And these ions come together and form a compound. Or what is the second possibility? That elements directly form the compound. So these changes having a certain name. If element is turning into atom, what we call that? We call that as atomization. If atom is turning into ion, then two possibilities are there, because a positive ion will lose electron, negative will gain. So for positive ion formation, because they are losing electrons, so we call that as ionization. But for negative ion formation, we call that as affinity or electron affinity. Affinity means like negative, because the negative ion, what they will do, they will gain electron, and positive ions are formed by loss of electron, and negative ions are formed by gain of electron. So when positive ions are losing electron, the energy is called ionization. But when negative ions are gaining electron, we call that as affinity. So what happened? Elements turn into atom, then atoms turn into ions. And how atoms can turn into ion? So atoms turn into positive ion, that we call ionization. And if atoms turn into negative ion, we call that as affinity. And ions form a compound. So when ions form a compound, what we call that as lattice energy. So this is called a lattice energy when ions form a compound. Or element directly form a compound. What we call that? We call that as formation of a compound. These are the terminologies used when we describe the formation of ionic lattice or ionic compound. That there are two ways that ionic compounds or ionic lattice can form. Number one, element first turn into atoms, and atoms turn into ions, and then ions join together and form a compound. And the second one is directly the elements form a compound. So if elements directly form a compound, we call that as formation. And this cycle is known as the Born-Haber cycle. Is it clear the idea of the Born-Haber cycle? I will give more examples related to how you can write this. Is it clear to everyone? So example, if they say complete the Born-Haber cycle for sodium chloride. So we have to complete the Born-Haber cycle for sodium chloride. Now what we should have? First we will have element. And then we have compound here. Then we should have ions. So if you want to complete a Born-Haber cycle for sodium chloride, which is NaCl. So the compound, what we need sodium chloride, so NaCl, we need in a solid state. Elements, what are the elements to form this sodium chloride? So we need one sodium, and we need chlorine. How it exists? Because a non-metal which exists as a diatomic molecule, so Cl2. But we don't need Cl2. We need only one chlorine. So it means we need half molecule of chlorine, because we need only one here. That's why half molecule. of chlorine. And then ions which are there, so we need sodium ion in a gaseous state and we need chloride ion in a gaseous state. So when we complete this, first element form the atom. There is one more thing, the atom part is also there. Because directly from molecule does not form the element. Element form the atoms in the gaseous state, so it will form, because sodium exists as a solid and chlorine is a gas. But when we have sodium gas, gaseous atom, and we have chloride gaseous atom, we call that as atomization. So this energy to convert the molecules into atom in a gaseous state, what we call that as, atomization. So this is atomization. Then atoms form the ions. So if atoms form the ions, it is two things. For positive ions, it is ionization because electron is removed, and for negative ion, it is affinity because electron is added. So it is the sum of ionization of sodium plus affinity of chlorine. So electron is removed from sodium and electron is added to chlorine. So that's why it is ionization of sodium and it is affinity of chlorine. And then sodium ion and chloride ions form sodium chloride. So when ions form a compound, what we call that as, lattice energy. And then when elements form the compound directly, what we call that as formation. So this is the Born-Haber cycle for sodium chloride. Is it clear how we completed the Born-Haber cycle for sodium chloride? Sometime you have to label the steps. Sometime they make it more detailed and you have to label those steps. If you remove one electron, you call that as first ionization. If you remove two electrons, it's called second ionization. So the same cycle will be there, but they might change and they might increase the number of the steps, but the concept remain the same. So now I will divide this into further more steps, like we have sodium chloride. Sodium is a solid state and chlorine in a gaseous state. First, what we did, sodium was solid, we convert sodium into gas, and chlorine we did not convert it till now. So because we convert only sodium, so what is this part? Because only sodium is converted in from solid to atom, so we call that as atomization of sodium. Because only sodium is atomized, chlorine is not atomized. Then the second step, we atomize chlorine as well. The term atomize means like we produce atoms in the gaseous state. So we atomize chlorine. So the equation, the overall it is sodium does not change in a gas state, but now chlorine is also there in a gaseous state. So what we call this change, the second step is atomization of chlorine. Because the first stage we atomize only sodium, the second stage we atomize. The term atomize means we produce 1 mole of a neutral gaseous atom. We call that as atomization. Then we remove the electron. Then we remove the electron from sodium. So sodium atom in a gaseous state turn into sodium ion, and there's already chloride ion in a gaseous state. So if electron is removed from neutral gaseous atom, and this is the first electron, so what we call that? We call that as a first ionization energy, because we remove 1 electron. Then this electron is added to chlorine. So when electron is added to chlorine, it will turn into sodium ion in a gaseous state and chloride ion, negative ion in a gaseous state. So when chlorine gain electrons, so what we call that as first electron affinity of chlorine. And this was the first ionization energy of sodium. And then these ions form the compound. So when these ions are forming a compound, it will turn into sodium chloride solid, NaCl in a solid state. So when ions form the compound, what does it mean? That is called lattice energy. So that is the lattice energy of NaCl. And when element form a compound, that's called formation. So that is a formation energy of NaCl, and this was a lattice energy of NaCl. So this is the complete diagram, and some of the arrows, as you can see, some of the arrows are pointing up, some of the arrows are pointing down. What is the significance of these arrows? If arrows are pointing up, it shows that change is endothermic, or energy is taken in. If arrows are pointing down, it means that change is exothermic, or energy is given out. So sodium atom turned into sodium gas. We have to supply energy to convert something from solid to gas, so that's endothermic. That's why arrow is pointing up. Chlorine gas, we have to convert, chlorine molecule we have to convert into chlorine atom. So we have to break the bond, that's why it is also endothermic. Then to remove the electron from the shell of sodium, we have to supply energy, that's why that is also endothermic. But when electron is added, chlorine is a non-metal by itself, it will gain electron. So that's why the first electron affinity will be exothermic. That's why the arrow is pointing down. And when ions come together, they will form a bond, they release energy. That's why lattice energy is also exothermic. And when elements form a compound, the formation will be exothermic as well. Is it clear, the concept of the Born-Haber cycle to explain the lattice energy? So in exam, normally they give this type of question. You have to uh, either write the equation, or you have to label the arrow, like what change it is representing. So before that, you have to memorize these definitions as well. So the definitions which are related to the formation of ionic lattice: enthalpy change of formation means when 1 mole of compound is formed from its element in the standard condition. Like you can see, when sodium in a solid state and chlorine in a gaseous state form 1 mole of sodium chloride, the energy is called enthalpy of formation. And how we represent that? Delta H means enthalpy, and F subscript F means formation. Then enthalpy of atomization means when we convert or when we produce 1 mole of a gaseous atom, neutral gaseous atom, we call that as atomization. Like here, sodium solid, it is already atom, but we produce sodium atom in a gaseous state, we call that as atomization. And it is always endothermic because you have to supply energy to break the bonds or to convert the molecule into atom. Then first ionization, energy required to remove first electron, we call first ionization. Energy required to remove the second electron from already the charge ion, we call that as second ionization. And it is always endothermic because you have to supply energy to remove electron. Then electron affinity. Electron affinity means when electron is added to atom, we call electron affinity. The first electron affinity is exothermic because it happened by itself, but the second electron affinity is endothermic. What is the reason why the first is exo but the second is endo? Because in the first one, it's a neutral atom and electron is added easily. But in the second one, it is already a negative charge. So oxygen example having a negative charge and electron also having a negative charge. So these like charges repel each other. That's why this electron is not able to transfer to this oxygen ion. So we have to supply energy to add the second electron. So first electron affinity is always exo, and the second electron affinity or third electron affinity will always be endothermic. Is it clear? And the electron affinity value become less exothermic as we go down the group. So it is easy to add electron to a bigger atoms as compared to, because what happened, they have more shielding effect. So electron affinity value become less exothermic. Like the energy which is released is less exothermic. So as we go down, like group 7 is there, we have fluorine, chlorine, bromine and iodine. So as we go down the group, there are more shells. So iodine atom is bigger and is having a greater shielding effect. So it will become less easy to attract electron to the atom to form a negative ion. So it will not easily attract electron because it is far away from the nucleus and more shielding effect as compared to that of fluorine. So this will release less energy and this will release more energy, because when stronger bonds are formed, energy release will be higher as compared to a weaker bond. Then the enthalpy of lattice formation, when ions in the gaseous state form the compound, we call that as a lattice energy. So you have to learn and memorize these definitions related to the ionic lattice. And what are the trend in enthalpy, lattice of enthalpy? It depends on the size of the ions. The size of the ion should be small as possible, and the charge on the ion should be large as possible. Like example, when we compare the lattice energy of sodium chloride with magnesium chloride. So sodium chloride will have a smaller lattice energy, or it will be less exothermic, and magnesium chloride will have a large lattice energy because ions are closer and the charge on the ion is greater, the net charge, whereas sodium chloride, the ions are larger and the size is smaller. So larger the ions, the less negative enthalpy of lattice or weaker attraction, and greater the charge, the greater attraction, so higher lattice energy. Is it clear? So the lattice of enthalpy become less negative as we go down. So when we go down, like example, if you have lithium chloride lattice, you have sodium chloride lattice, you have potassium chloride lattice. So potassium chloride is larger in size compared to sodium, and sodium is larger in size compared to lithium. So lithium will have a higher lattice energy, lithium chloride, as compared to potassium chloride, which will have a lower lattice energy. So this is the main concept of the lattice energy, that the lattice energy means when ions in the gaseous state form the compound, and the lattice energy is higher depending on the size of the ion and the charge of the ions. And when we compare the lattice energy using a Born-Haber cycle and using the electrostatic method, this is called theoretical, and this is called practical. So practical values are always higher than theoretical values. Like theoretically, example, sodium chloride. Theoretical value for sodium chloride is 700, but practical value of sodium lattice energy is minus 715. So that is higher lattice energy, means it is strong, and theoretically it is weaker. What is the reason why the theoretical values are less and practically is higher? Because when we consider ions are perfect spheres. This is our consideration, that when ions are there, positive and negative ion, they are perfect spheres. But in practical, it's not a perfect spheres. Ions are not perfect spheres. Ions are actually polarized or distorted. The negative ions changes their shape, so they come closer to the positive ion. That's why the lattice energy increases. Practically, this is what happened. So practical lattice energies are always higher than theoretical lattice energies. This part we'll discuss in detail in the next session. Any question related to the class today? We will discuss about theoretical and practical lattice energies in the next session. Any question or a doubt related to the class today? So I'll end this session and share this with you.